This video is going to demonstrate how to solve a linear programming problem when we have to do it from start to finish. And it will also help prepare for the course Proficiency, which you will need to take shortly after this. Please have these notes in front of you and pause this video so you can read through the word problem. The first step in every one of these problems is to define our variables that we're going to use for the rest of the time that we're solving this. And there's two things that I am producing, and it is the lockup models and the freeze-up models. I think I'm going to let X be whatever comes first. And as I look through the problem, I see that freeze-up models comes first. So I'm going to let X be the number of freeze-up models. Remember, be specific when you're defining variables. And I'm going to let Y stand for the number of lockup models. Once I have my variables defined, the next thing I need to do is set up my equation that I want to maximize or minimize. And I notice that it says we'd like to maximize our profits. So that is a big clue that I need to set up a profit equation. And I have to read through my word problem and find keywords like profit. And I see that the profit for a freeze-up model is 45 and the profit for a lockup model is 50. So if my variables are defined the way they are, my profit equation is going to be 45x plus 50y. By the way, it doesn't really matter which way we define the variables as long as we're consistent. I just like to use it, I like to use the variables that come first as the x and the ones that come second as the y, but it really doesn't matter. The next thing I'm going to need to do is set up what my constraints are. And remember that I have two of them that are very easy because I can't produce any negative models of computers. So let's label these constraints. And again, I have two that are very easy. X has to be greater than or equal to 0, and Y has to be greater than or equal to 0, because I can't make any negative computers. One of my constraints is going to deal with cost. The cost for a freeze-up model is $250, and the cost of a lockup model is $400, and we cannot afford more than $70,000 worth of the two models. Money, money, and money goes together. So that's going to be a 250x plus 400y, and that's going to be less than or equal to 70,000. And I have one other constraint that I'm going to have to set up, and this is the one that I think is the hardest one, because it's this sentence right here. The combined sales of the lockup and freeze-up models will not exceed 250. And that's telling me that the number of freeze-up models, X, plus the number of lockup models, Y, has to be less than or equal to 250. Now, as long as we have the constraints set up, let's go ahead and do the next step where we're going to have to figure out what the X and Y intercepts are for those two constraints. So let's make an XY table. I'm going to make an XY table for this top one, and I'm going to let X equal 0 once, and I'm going to let Y equal 0 once. Again, this is the cover-up model. If I plug in 0 for X, the 250X is gone. And I'm going to have 400 times Y equals 70,000. So I would need to take 70,000 divided by 400, and I would get 175. If I plug in 0 for Y, the 400Y is gone. So I have 250 times X equals 70,000. And if I divide 70,000 by 250, I would get 280. The XY table for this second constraint is very easy. If I plug in 0 for X, cover the X up with your thumb. Y would be equal to 250. If I plug in 0 for Y, cover up y with your thumb. X would be equal to 250. So on the next page, we need to graph these constraints, find the shaded area, figure out what the corner points are, and then test the corner points. All right, let's start graphing the constraints from the first page. I'm going to graph the ones that were 0, 250, and 250, 0, because that'll give me a good scale for my graph here. All right, 0, 250, I need to estimate where it is, and I'm going to estimate 0, 250 to be about right here. Make sure you label stuff as you plot it at 0, 250. 250, 0 needs to be about the same amount of spacing to the right. So maybe something about like this. And again, label it as you graph it. So that coordinate is 250, 0. I'm going to look at my inequality symbol, and since it is less than or equal to, I'm going to draw in a solid line. And it's going to end up that I shade underneath this, but I'm not going to do any shading yet. Now let's graph the second one. I need to plot the point 0, 175, which is not going to be as high as 0, 250. So maybe something about like this. Label it as you plot it. 280, 0 is going to go farther than 250, 0, maybe about here. Look at the inequality symbol. It's less than or equal to, so draw in a solid line. And then it turns out that I'm going to shade underneath this also. So I'm going to shade underneath both of them. And remember the two easy constraints, x is greater than or equal to 0 and y is greater than or equal to 0. I already graphed those just by drawing this sketch in the first quadrant. I'm going to have a total of 4 corner points. 3 of them I can label right away. Out of 0, 175 and 0, 250, 0, 175 is a corner point. Out of 250, 0 and 280, 0, 250, 0 is a corner point. This corner point here, 0, 0, is pretty easy. I need to solve for this corner point where the two lines cross. In order to solve for the corner point where the two lines cross, let's write down what equations we graphed to get that point. I'm going to now make them equations because I don't need the inequality symbol anymore. I already have the line drawn in, and I already have the shaded region taken care of. So one of them was 250x plus 400y equals 70,000. And the other one was x plus y equals 250. Although the elimination method is probably what everyone would like to use for this, substitution would really be easier, but I will solve this using the elimination method because I think that's the way most people would want to do it. If I want to eliminate the x's, I'd have to multiply the bottom equation by negative 250. If I want to cancel out the y's, I'd have to multiply the bottom equation by negative 400. I think I'd rather multiply by a negative 250 instead of a negative 400. So I'm going to multiply this bottom equation by negative 250. And now let's write down what our new equations are. Top one stays the same. It's going to be 250x plus 400y equals 70,000. Bottom equation is negative 250x minus 250y equals negative 62,500. Bigger numbers here, but let's just be careful with them, and it's solving an equation just like we've done the whole chapter. If I add the x's together, they add up to 0. Good, I wanted to eliminate them. If I add a 400y and a negative 250y, I get a 150y. And if I add together a 70,000 and a negative 62,500, I get a 7,500. I have to divide both sides by 150. So my y value is going to be equal to 50. And once I figure out my y value is 50, I think I'm going to plug that into the bottom equation, because then I would have x plus 50 equals 250, and that's really a very easy problem to solve. X is going to be equal to 200. So my missing corner point, my fourth corner point, I'm going to go ahead and label it right now, is going to be the ordered pair 200, comma 50. Now I've come to the portion where I want to test the corner points. So it's been a while since we set up our profit equation. I'm going to rewrite what my profit equation is. And this is from the other page. Profit was 45x plus 50y. And now I'm going to write my corner points down. 0, 0, and 0, 175, and 200, comma 50, and 250, comma 0. Those are my corner points. Remember, my first coordinate is an x, my second coordinate's a y. So what I need to do is plug these into my profit equation. So here's the solving part. First one, I'm going to have 45 times 0 plus 50 times 0. It's not too hard to know that that's equal to 0. If I plug in 0, 175, I'm going to have 45 times 0 plus 50 times 175. And this answer is 8750. So if I wanted to make a profit of 8,750, I would have to produce 175 lockup models. 200, comma 50 is going to be 45 times 200 plus 50 times my y-coordinate of 50. Doing this on your calculator, this is 11,500. So in order to make $11,500, that's my profit. Remember, I'm plugging everything into the profit equation. I would have to produce 200 of whatever x stands for, which is freeze-up models, and 50 of whatever y stands for, which is lockup models. Last corner point, 250, comma 0 would be 45 times 250 plus 50 times 0. And this is going to give me 11,250. So if I wanted to make $11,250 profit, I would have to produce 250 of whatever x stands for, which is freeze-up models. Obviously, if we look at this, I hope you quickly realize that the maximum profit is this one right here. So let's change that math sentence back into an English sentence. So to make $11,500, remember we are plugging everything into our profit equation, so that's our profit. So to make $11,500, produce 200 of whatever x stands for. So 200 freeze up. $200 freeze-up models, and 50 of whatever y stands for, and y stands for lockup models. And with this conclusion, this was one linear programming problem from start to finish.